Hello, today I'm going to demonstrate how to find the theoretical yield and percent yield for a chemical equation. First, let's look at our question. Solid magnesium oxide can be made by heating magnesium metal in the presence of oxygen gas. A. Write a balanced chemical equation for this process. B. If 10.1 grams of magnesium reacts with 10.5 grams of oxygen, what is the theoretical yield for this reaction in grams? And C. If 11.9 grams of magnesium oxide are produced, what is the percent yield for this reaction? Part A is asking for a balanced chemical equation, so let's locate our products and reactants first. The problem tells us that magnesium oxide is made, so this is obviously going to be our product, and our reactants will be oxygen gas and magnesium. We have Mg, which is magnesium and has a charge of 2+, and is also a solid. Then we take O2, which is oxygen gas and has a charge of -2, which is a gas. These are heated to create MgO. On the product side, we only have 1 oxygen and we have 2 on the reactant side. So for this equation to be balanced, we would need 2 oxygens, so we place a 2 in front of the MgO, giving us Mg plus O2 creates 2 MgO. Now there is 2 Mg as well as 2 oxygen. The oxygen is balanced, but now the magnesium is off, so you would need to add 2 in front of the Mg on the reactant side, and you now have a balanced chemical equation. Moving on to part B. Part B is asking for the theoretical yield of this reaction. To begin, we would have to find the limiting reactant, which is the reactant that limits the amount of product formed. Since we have 2 reactants, we would need to find both and see which number is smaller. We'll start with the first one they give us, which is 10.1 grams of magnesium, and you need to get from grams of magnesium to moles of MgO. So first you have to start by converting this all. So you would start with 10.1 grams of Mg and convert it to moles. So you would times that by moles of Mg, and you would put the molar mass on the bottom, which is 24.305 grams of magnesium, and that is located on the periodic table. But we are still not at the moles of MgO, so we would go back to our balanced equation and see that for every 2 moles of Mg, there are 2 moles of MgO. So you would set that up as 2 moles of MgO over 2 moles of Mg, and that would give you 4.16 moles of MgO. So we would do the same thing for the second one they give us, which is 10.5 grams of oxygen. So you set that up, and it's 1 mole over 32.00 grams of O2, which is also found on the periodic table. And then from moles of O2 to moles of MgO. So for every 2 moles of MgO, you only had 1 mole of O2. So you set that up as 2 moles of MgO over 1 mole of O2. And that gives you 0.656. So we can see that the 10.1 grams of magnesium was the limiting reactant since it was left with less. But the problem is asking for the reaction in grams, not moles. So we would have to convert this to grams of MgO. You set this up, you take the limiting reactant, which is 0.416 moles of Mg, and you multiply it by the molar mass of MgO, which is 40.31, and you put that over 1 mole of MgO. And your answer would be 16.8 grams of MgO. Now for part C, it's asking for the percent yield, and we know that that is the actual over theoretical times 100. So the actual is given in the problem, which is 11.9 grams of MgO, and we found the theoretical in part B, which was 16.8 grams of MgO. So we set that up and we get 11.9 grams of MgO over 16.8 grams of MgO. You multiply that by 100 and you get 70.8 grams of MgO.